All right, let's take a look at some numbers here. I'll talk about the fluids. But Excel, usually in the back of the book or in the front of the book, you have some data like this. So these are some numbers. Acceleration due to gravity. So this is kind of like the gravitational pull. The units are G. The 1G is equivalent to 9.80665 meters per second squared. This is how we read that. Do you think this is exact number or approximate number? Exact. Approximate number. It's approximate number because this is only known to how many sig figs here? 6, you know, but there could go on. It's not by definition. Things that are defined are going to be exact numbers. Speed of light in a vacuum is 2.9979248 times 10 to the 8 meters per second. Exact number or approximate? It's approximate, but this is a lot of sig figs. How many sig figs is that? 9. In physics, when I memorize this number in physics, you know what I memorize? 3 times 10 to the 8. I memorized it to 1 sig fig. But in chemistry, I usually memorize it to 4 sig figs. In chemistry, I memorize it to 2.998. Round that. But round that by dropping that. So 2.998 times 10 to the 8 meters per second should be good enough for most all calculations. We have something called the gas constant R, which is 0.0820573. Exact number or approximate? Again, approximate number. How many sig figs is it? 6 sig figs. Good. Does everybody see that? Or okay. This is 6 sig figs. Our book, Krakolici, asks us to memorize it to 3. To 3 sig figs, what would this number be? 821. But it's kind of a waste. If you're going to memorize this, memorize it to 4, because the next semester, Chem 1A, you have to have it memorized to 4. And so what you have to do is you have to erase it and then re-memorize it to 4. And so it's much easier to memorize it to 4 to begin with. That way you don't have to do it again later. And so what is this to 4 sig figs? This would be 0.08206. That's it. 8206. 0.08206. This one we have to memorize. Speed of light we don't have to memorize. G we don't have to memorize. This is for physics. We just memorize this one. These ones are equivalent, but they have different dimensions. And so rather than measuring something called pressure in atmospheres, we can measure pressure in bar. 1 bar and 1 atmosphere aren't the same, so these numbers are slightly different. Rather than 82, this comes out to 83 in terms of bar. Or, you know, it turns out an atmosphere times a liter is something called a joule. All 3 are equivalent, but they're just at different units. You know? That's it. So this would be like saying, okay, you know, 12 eggs. Instead of calling it 12 eggs, you could call it 1 dozen. So it's just different, using different units to change the number. This is the charge on what's called an electron. An electron is a piece of an atom. You know, atoms are made up. Actually, atoms are made up of protons, neutrons, and electrons. So this is something that makes up atoms. It's the charge. We'll talk about that later. This is the mass of the electron. None of these are exact numbers, you know, but there are a lot of sig figs. You know, all these numbers here. A lot of sig figs. We don't necessarily use that many sig figs. We'll round it to, you know. Are there any other quizzes? Do you have a quiz? Let me get that. if we look at this one, wow, this one might have been useful. But this one is not useful, actually. I don't think this will be very useful at all. 1 meter is about 39 inches. But as far as this goes, is this an exact number or approximate? In exactly 1 meter, there are approximately 39.37007874 inches. Does that make sense? What about this one below it? 1 inch is approximately 2.54 centimeters, or exactly 2.45 centimeters? It's exact, 2.54. This is exact. So I don't memorize the top one. I memorize the bottom one, because that way I don't have to worry about sig figs. And so if I know this bottom one, then I'm all set. So let's take a look, because that's the only one I pretty much have to memorize. Well, I had to memorize something else too, but okay. So let's take a look at that problem I gave you. The hydrogen atom. I talked about the hydrogen atom, right? I didn't talk about the hydrogen molecule. This is the hydrogen molecule. It consists of how many atoms? 2 atoms. Each atom is approximately 100 picometers. And so the length of this hydrogen atom would be about how many picometers? About 200 picometers. About 100 picometers this way. So it'd be like 100 picometer by 200 picometer, kind of cylindrical thing. So if we're looking at the atom, so it's about 100 picometers. How many sig figs is that? This is ambiguous, because this could be 1, 2, or 3 sig figs. But in this case, it's about 1 sig fig, maybe 2 sig figs. Because, the range, if it's 1 sig fig, then that would give us a range between about 55 to 104 picometers. So about 55 to 140 picometers. Wouldn't it be 149? Well, we round it to a 1 sig fig. And so it's 149, we drop the 9, that gives us 150, which would be 2 sig figs. Too many sig figs. If we had 2 sig figs, then you're right. This one's tricky. Sorry, I screwed this one up. It should be between. Would round 0.6. This is a bit tricky because of the 100, but I'm not exactly correct here. And so we need something that rounds to 100, but it's kind of tricky. And so it'd be like 51. If you round this to the nearest 100, then it would round, I guess, up to 100, right? Versus 50 could go either way. If it were 50, you could either round it down to 0 or round it up to 100, to the nearest 100, right? But by convention, if it's a 5, we round up or down. We round up. So we round up. And so 50, it could be 50. 50 would round up to the nearest 100, would be 100. 140 to the nearest 100 would be 100. Now, if it were 3 sig figs, that'd be a different story. The 3 sig figs would be a lot easier. The range would be 99.5 to 100.4. So this would round up to 100, this would round down to 100. Something like that. Does that make sense? So it depends. Well, this one I'm just calling 1 sig fig, 1 or maybe 2 sig figs. Depends on how much you have it memorized. The actual, if this was 53, it'd be 106. But we know about atoms. Are atoms hard shelled? Or are they kind of soft? They're kind kind of soft. 100 picometers. Now, what we do in the dimensional analysis is we look for something that gets rid of picometers. So is there something that relates picometers to something else? And there is. You know, there are two ways I could represent this conversion factor. The first way I could do it is pico. What does P stand for?
10 to the negative 12.
10 to the negative 12 meters. So this is equivalent to a picometer. Picometer. And so we could say 1 times 10 to the negative 12 meters is 1 picometer. Or we could do it this way. Because of exponential, the properties of exponentials, we could say that in 1 meter, you know, if I took a meter stick like this and chop it up into, or divide it into how many pieces? 1 trillion pieces, then each piece would be a picometer. So 1 meter contains 1 trillion picometers. Or this is a Hassel, so we use scientific notation. 1 meter contains 1 times 10 to the positive 12 picometers. In 1 meter, there are 1 trillion picometers. These are they exact or approximate? These are exact, and so it's infinite sig figs. And so it doesn't matter which one you use. Either one's fine. I like to remember it like this. In 1 meter, there are 1 trillion picometers. But it doesn't matter because all of them will give you the same answer. So picometers, we get rid of picometers, that leaves us with meters. Now I asked you how many inches, and there was a conversion factor for meters to inches here. But I told you I wouldn't bother memorizing this conversion factor, it's a waste of time. This is a waste of time to memorize. This is a lot of digits, right? This is much easier to memorize, so I memorized this one here. 1 inch equals 2.54 centimeters. I would have had that memorized. And so what I would have done here is I would have went from meters to centimeters. Now, if I take a meter stick like this, now how many centimeters are in a meter stick? You know?
10 to, you have to subtract.
Well,
12 minus 10 to 2, so 10.
yeah, 100? 100 is correct. There are 100 centimeters in 1 meter. And so I could just use that. You know, I could just say there are 100 centimeters in 1 meter. Or I could say centi is equivalent to what? Centi means 10 to the minus 2. And so I could say 1 centimeter is equivalent to 1 times 10 to the minus 2 meters, because 10 to the minus 2 is a centi. So this would be a centimeter. Or 1 centimeter is equal to 0.01 meters. This would be decimal form, converting it from scientific notation to decimal. Or this is the one I remember easiest, so I'll use this, 100 centimeters in a meter. And then we need something that gets rid of centimeters. So is there something, well, you should memorize this one, if not now. 2.54 centimeters is exactly 1 inch. Exactly 1 inch. Like I said, I don't have to put the 1 here. I could leave off the 1 like this, or I could put it in. Since I started writing it here, I'm just going to be consistent and write it all the way through. Here. That's exact. And so the centimeters cancel, and then this gives us the right dimension. The right dimension is the inch. That's what we want. And so what is the calculation? So let's go back to the calculator here and punch it in. I'm going to clear this. Yeah. And So I start off with 100, so 100. And then I'm just going to do the numbers. I'm going to do divided by 1 times 10 to the 12th. And so divided by, now I have to do 1 here, then times 10 to the 12 here. So that would be 1 times 10 to the 12th, or 1e12, times 100. Just go in order. Divided by 2.54. And then that's it for the math. So we did the dimensions, now we're doing the math. All right, now this gives me 3.937 times 10 to the minus 9 inches. So what I'm going to do is I'm going to convert this into decimal form. When I convert this to decimal form, I'm going to bring this up to 0. From minus 9 to 0. So I'm going to make this number bigger. Therefore, I've got to make this smaller. So I'm going to make it smaller by, so I need 8 zeros after the decimal. 1, 2, 3, 4, 5, 6, 7, 8. And then this is going to be 3.937 inches. So the hydrogen atom's diameter is about, 0.00000003937 inches. It's really small, as you'd expect. You'd expect the hydrogen atom to be very small. Are we allowed this many sig figs? No, officially, how many sig figs are we allowed? We're allowed, well, it depends. If I call this 1 sig fig, then we're only allowed 1 sig fig in our answer. If we're only allowed 1 sig fig in our answer, which is going to be approximately 0.000000004 inches. So this is going to be equal to 4 times 10 to the minus 9 inches. Okay. Are we out of time already? No, actually, we're not. We go till when? 12:20 today?
Yeah,
Oh. All right, not 12:35.
tomorrow.
Tomorrow. All right. All right. Well, that's it for today.